Hello and welcome back to another episode of Feather News. By the time you're watching this, it's probably the 29th or 30th of August. And first of all, I just want to apologize that I didn't create a video last week. This was because I was moving place and logistically it wasn't possible for me to do so. I also don't have a green screen with me here, so the lighting in the background was not ideal, so I'm not recording my video today. However, I think I should have used this approach, which is the green screen but without the green screen. So ByteDance, aka the creators of TikTok, released a robust video matting algorithm which basically allows for isolating and segmenting people from the foreground of a video from the background. Now, this has obvious use cases such as in video conferencing and social media entertainment videos, as in through TikTok or Instagram. The algorithm itself uses a recurrent architecture to exploit the temporal nature of videos, which is an improvement over the current state of the art, which just perform the segmentation and matting process frame by frame. And this has a couple of advantages, one of which is the improved matting robustness. So when an individual frame is ambiguous, for example, the foreground color is similar to the passing object in the background, the model can better guess the boundary by referring to the previous frames in the video. And the model itself is an encoder-decoder architecture consisting of CNNs, GRUs, and something known as a deep guided filter, which is a component that efficiently upscales images. So previous work attempts to use segmentation as part of the matting objective, but in most cases the model overfits to the matting. So the authors here use a 4-stage training strategy to enforce the model on matting and segmentation objectives simultaneously. This involves some clever tricks to help keep the model robust to different dimensions of videos and different qualities of videos as well. We all know what structured query language is and SQL databases, and as the name implies, they need to store data in a structured format in order to be able to search and query it. Now, obviously, this doesn't enable cool tasks such as running complex queries on unstructured data. We can't exactly list all the female athletes who were born in the 20th century just off the bat in an open database. So Facebook AI Research have recently been looking into something called neural databases, which attempt to bridge the gap on NLP and databases. Previous work has performed well on small data, and this is just, standard transformer-based models, but they don't actually scale to larger data. Now, alongside natural language queries, which can be decomposed into SQL queries, this line of work can hopefully enable searching over some vaguer semantics, such as which posts by this user contain hate speech. Their new work introduces WikiNLDB, which is a graph-like database based on Wikipedia and is structured as such. Is a tuple of subject, relationship, and object. So an example could be a subject being Elon Musk, the relationship being is the founder of, and the object being SpaceX. And they also introduce a modular transformer-based architecture which performs well on this database and can scale well to larger databases. How this model works is probably a bit too deep for this video, but I have linked the paper below, so I'd recommend checking it out if you were curious about it. This line of work has a lot of overlap with open domain QA and multi-hop reasoning, but you can read the paper to also find out the subtle and key differences between them. We've all heard of pre-trained language models by now. Now, foundation models, as we're calling them here, are in fact a paradigm shift in AI, and they serve as the backbone of many modern systems in both NLP and wider AI, such as computer vision and robotics. So while extremely powerful, the AI community has not yet extensively analyzed the drawbacks of these large language models. So this paper, authored by Stanford's Human-Centric AI, it was authored by more than 100 people, and it's a 200+ page report, which looks into the opportunities and risks of these kinds of models. It also tries to show when and where these models fail, alongside the properties within them. Now, the paper features authors you've probably heard of, such as Percy Liang and Fei-Fei Lei, and two of the properties which they focus on are emergence and homogenization. Now, emergence in this context is the behavior of systems being implicitly induced rather than explicitly constructed. And homogenization is the consolidation of, what were different methodologies into one way of doing things and building machine learning systems that have a wide applicability. Now, the paper discusses capabilities of these foundation models in different AI disciplines, such as NLP, CV, robotics, even philosophy, some applications, such as in law, education, and healthcare, the technology behind them, including the data that they were trained on, and their long-term effects on society, such as potential misuse, environmental effects, economic benefits, and so forth. Now, reconnaissance blind chess isn't really a new piece of research. However, there is a Neurox competition for it, which is up and coming. So I think it's pretty cool, and it doesn't have that much exposure behind it, which is why I'm putting it in this video. So reconnaissance blind chess it's a blind chess variant which has been designed for AI research. Basically, every turn a player can select a 3x3 grid on the chessboard to reveal, and then they're allowed to move their piece. So RBC algorithms aim to solve problems with imperfect information that require long-term strategy. The explicit choices of observations also have to be modeled because there is no common base of knowledge. And it's part of the new hidden information games competition, which is being organized by DeepMind and Czech Technical University. As I mentioned, there's a Neurox competition for it, so you can submit your bots for it. But if you were just curious about how to play the game and what it's like, I've linked it below, and you can actually play against some of the bots completely free of charge. So check it out. I've played a couple of games, and I have to say it's probably as fun, if not more fun, than real chess. Finally, do vision transformers see differently than CNNs? So we know that vision transformers have recently gained popularity, surpassing CNNs on many tasks. However, work into how the representations are different between the two networks hasn't been overly analyzed. So this recent work by Google Brain shows the many differences between ViTs and CNNs. One key difference is how ViTs tend to incorporate more global information than ResNet and /CNN based architectures at lower layers. Now, interestingly, skip connections are more important in ViTs too than in CNNs, which is kind of funny considering the premise of ResNet is these residual connections. They do have other findings, so visit the paper for a full list and a comprehensive overview. This image here is basically a visualization of the layers with vision transformers and CNNs. So they use a method known as centered kernel alignment, which basically can compare neural networks with each other. And we can see here that in vision transformers, there is more, or we have similarity between the lower layers of the network and the higher layers of the network. So for example, we can take layer 20 here, and if we look at layer 140, we can see that there is some similarity between the two. Whereas in ResNet, we don't see this at all. That the similarity between higher and lower layers of the network is much lower. So we can take a look at layer 20 here, and we see that there's almost no similarity between layer 110, for example. Anyway, that's all from me for this week. Thank you very much for staying tuned. Like, subscribe, hit the bell button, all of that. You guys know the drill by now. And if you want a way to share, deploy, and monetize your machine learning models, all completely free of charge, then visit feather-ai.com for a free and easy way to do so. Anyway, that's all from this week. Thank you for tuning in.